Hello. Hello and welcome to Scope Summit 2022. I'm Ruth Levine. I'm Olin's Director of Strategic Industry Partnerships, and we are very excited to have everyone here today. The last time we were all together for Scope Summit was in 2019, and it feels great to have an audience with students, faculty, staff, parents, and sponsors here, and many other visitors joining us live stream. So we will be hearing very shortly from our students about their scope projects. And first we have just a couple of things we'd like to do. And I'm going to turn the mic over to Jason Woodard, Dean of External Programs and Partnerships, for a special presentation.
Thanks, Ruth. Olin's president, Dr. Gilda Barabino, was planning to be here to make this presentation today, and she's very sorry that she couldn't join us. The silver lining for me is that having served as faculty advisor for 2 scope teams sponsored by the Santos Family Foundation and been peripherally involved in 2 or 3 others, it is a great honor and an absolute treat for me to do this in her place. So here we go. Welcome to Scope Summit. We're so proud of our seniors and very glad you're able to join us to see the results of their scope projects. Today, we'd like to give special thanks to the Santos Family Foundation. The foundation stewards, Paul Santos and Ann Stewart, have sponsored 8 scope projects and mentored a total of 38 Olin students through these projects. Paul and Ann are also parents of Dante Santos, Olin class of 2014. Each year, the foundation has worked with the scope leadership team to define a project undertaking that can help save lives. For the past 5 years, the Volpe National Transportation Systems Center has joined this partnership to help identify and mentor projects that can save lives on a national scale. Alex Epstein, Olin class of '06 and senior engineer at the Volpe Center, shared these words about working with the foundation. From my first conversation years ago with Paul and Ann, I was struck by their vision of giving Olin seniors a chance to feel what it's like to make an impact on saving lives, whether it's today or long after they've graduated. Olin and the SCOPE program are very lucky to have the Santos Foundation championing the long game of taking Renaissance engineers and training them on the national crisis of traffic safety. In addition, several alumni who were on Santos Foundation SCOPE teams sent messages for us to share with Paul and Ann. I'd like to share a few excerpts from these letters now. James, from the class of 2015, said, "I could not have known how the choice to work with the Santos Foundation would fundamentally shape the course of my professional career. With the harsh truths of on-road vehicle fatalities deeply ingrained into my psyche, I am continually reminded of the bigger picture, the larger promise of autonomous vehicles. Our research from that project indicated that a Vision Zero world could only be achieved with no humans behind the wheel. And while it was uncertain if society would willingly relinquish vehicular control to faceless machines, self-driving technology is still our best hope. That discovery kept me motivated to enter into and remain in the self-driving industry." Gabriel, from the class of 2018, said, "We were given the opportunity to really dig into driving safety without profit as a motive, and I think that let us get to the core problems and come up with effective solutions. Getting to focus on safety through that lens revealed a lot about how much room for improvement there is and how simple some of the solutions are." Paul, from the class of 2020, said, "Paul and Ann were nothing but supportive, encouraging, and genuinely excited by the work that we did and encouraged us to consider different viewpoints and stakeholders and anticipate potential roadblocks. Their experience and connections proved to be invaluable in our work." Paul and Ann are joining us via live stream today. Let's offer a round of applause. This fall, we will be installing a bench on campus near the parking lot with the inscription, "In recognition of the Santos Family Foundation's support of Olin student work to save lives on the roads." Further, we would like to work with Paul and Ann to add a message to the bench from the foundation for all to see when they are getting into their cars before leaving campus. Thank you again to the Santos Family Foundation. And now back to Ruth.
We are grateful to all of our wonderful sponsors and to the Santos Family Foundation, and I'd like to tell you who our sponsors are this year before the students stand up for their presentations. So this year's sponsors are Air Partners Aerodyne, Amazon Robotics, Blue Origin, Boston Scientific, who has had a SCOPE project every year since the beginning of SCOPE. You won't actually hear about that project today because that work is going to continue over the summer. The Dassault Systems Foundation, supporting a SCOPE team's collaboration with the Monterey Bay Aquarium Research Institute, Ford Motor Company, GE Healthcare, Johnson & Johnson, Pfizer, the Santos Family Foundation supporting a SCOPE team's collaboration with the Volpe National Transportation Center, and Watts Water Technologies sponsoring 2 projects this year. I'd like to introduce Scott Hersey, who is the SCOPE Faculty Director and Associate Professor of Chemical and Environmental Engineering, to tell you a bit more about SCOPE and introduce the project.
All right. Hi, everybody. I just want to give you a quick orientation to SCOPE as a program, so you have a little bit better context for the projects that these students did and the presentations that you're about to see. So SCOPE is a student-centered learning experience that sits on the foundation of Olin's project-based curriculum. And through SCOPE, faculty advisors and liaisons from sponsors come alongside student teams as they work on a real-world project over the course of a year that has some kind of significance for the sponsor. We see SCOPE as a true capstone in the sense that it's the culmination of an entire curriculum that looks like the type of open-ended, real-world, self-directed projects that we ask our students to engage with in SCOPE. SCOPE, it advances a lot of different goals. Somebody's phone, we found it. That's what mine sounds like when I find my iPhone, so it's found. SCOPE is set up to advance a lot of goals. We advance and also assess a lot of different goals, but at a fundamental level, there are 2 really important goals that we hope to achieve through SCOPE. Through compelling and complex real-world projects executed in collaboration with external partners, we first provide opportunities for our students to develop personally and professionally. We also, through these projects, create value for our sponsors and for the world. And so through SCOPE, we fundamentally challenge the assumption that an undergraduate degree is a prerequisite for creating value in the world. Instead, our aim is to provide opportunities for our students to develop while they are creating value.
I realize I should have stayed up here. Scott and I are going to share a bit of this presentation back and forth. So when we begin to talk with an organization about about SCOPE and about possibly participating in the program, we spend a lot of time looking at this particular question: what makes a good project? And every engineering manager has mission-critical problems that they're working on every day, and that's what their own engineering teams are working on. But every engineering manager also has a mind full of what we'd call class 2 problems, problems that could make a really big difference if they're addressed, but that you may not have the right enough time, the right skills on staff, the right facilities to be able to pursue those projects in-house. And, oops, let me go back there. This is what we call a class 2 problem that makes a really great project space for SCOPE projects. We're not really interested in class 1 problems for SCOPE because they're just not right for an educational exploration, and we're not interested in what we would call a class 3 problem, which is something that might be interesting to look at, but the results will sit on a shelf, and those projects are just not as well motivated. And if the company's not as motivated, then the students won't be as motivated, and it just won't provide the right experience that we want for either the sponsor or for the students. So to give you an example of the kinds of projects we talk about in that class 2 space, it's a pretty big variety of projects, and you'll find that out, that this is what the students will be talking about. They'll see that their projects are quite varied, but class 2 space can include anything from improved or new kinds of user interfaces, manufacturing challenges or improvements to design for manufacture, looking at new technologies to address existing client needs, or looking at existing technology to potentially look in new product directions. So those are the kinds of things that we talk to companies about and that we look for. You'll see that many of our companies have sponsored projects for numerous times. In fact, I think every project this year, we've worked with these sponsors in the past at some point, some for multiple years in a row, and some coming back occasionally every few years to do another project. And we do a fair amount of debrief afterwards and ask our companies what the value that they're getting from these projects is. And really, probably the primary meat of it is that companies find it an opportunity to have students who are really smart. They're coming at a problem from outside the company culture, looking at it differently, bringing different training, and can come up sometimes with quite interesting insights and unexpected solutions. Another reason companies participate is to build a presence on campus. We work together in other ways with companies. Our companies often recruit our students for internships in the summer, as well as for work after graduating. And finally, the companies that are supporting SCOPE are making a commitment to Olin's greater mission to really study undergraduate engineering education, figure out how to do it better, and share that with other schools, other engineering programs, and that hopefully leads to many engineers who are better trained and can make a bigger impact on the world.
Okay, there's two mics. So I want to give you just a little bit of a sense of the diversity of the projects that you're going to see today. You're going to see a whole wide range of different types of projects, and that diversity spans several different spectra. For one, the disciplinary domain of these projects is really different from team to team, and that's whether this is a mechanical or electrical or robotics engineering project or a design project. And beyond that disciplinary domain, all these projects sit in different social, technical, and ethical contexts that student teams have navigated with their sponsors over the course of the year. There's a lot of different starting points for these projects. Some teams started with a pie-in-the-sky idea that needed some validation and proof of concept. Other teams picked up projects that other SCOPE teams had already been working on for 1 or more years, or that had been worked on with their sponsor company before it came into their hands. Similarly, the endpoints are very different from team to team. Some teams dove into deep research and user engagement, and at the end of the year delivered insights and recommendations to their sponsors. Other teams developed prototypes that were tested, that were iterated and refined, and they handed something to sponsors that's ready for commercialization. Finally, these projects all have a different set of confidentiality constraints and IP assignments. You may notice that in some of these presentations, teams are going to focus a lot more on their process than on where they ended and what exactly they created. That may be because of confidentiality constraints. Similarly, at the poster session, you may have some deep curiosity about where some project ended, and if a team can't tell you exactly all the details that you're looking for, they may tell you, we'll tell you up to this point, but then we've got some confidentiality constraints. Okay. I want to thank our sponsors again. All 11 of these sponsors brought really compelling projects into SCOPE this year. And we want to thank you all, not just for enabling these projects through your sponsorship, but also your commitment throughout the year to have liaisons that were engaging with teams, that are helping them sift through technical problems and reach a successful endpoint that, importantly, can also be integrated into your organization to have a life beyond SCOPE. So thank you all so much. Also want to thank the team of people that has been with all of these students every step of the way. The SCOPE leadership team that includes Ruth Levine, who you've been hearing from, is our Director of Strategic Industry Partnerships. Jessica McCarthy is a Program Director in the Office of Externally Partnered Programs, as well as the teaching team of Alessandra Ferzocco, Jessica Townsend, and Jason Woodard. All these people really walked alongside these teams. The teams deserve every bit of credit for what you're going to see today, and These people were with them every step. So thank you all so much. I want to give a personal thanks to you all as well. This year was a heavier lift as an advisor or a program coordinator because I was out for a couple different stretches on parental leave. And I have a new son who's awesome, and I know he's awesome because I took parental leave. So thank you all. Yeah. Also want to thank our subject matter experts. These are folks from the Olin community who have some domain expertise in some area relevant to different projects that were in scope this year. These are folks who gave their time in exchange for a free lunch. And they sat in on design reviews, they interacted with prototypes, they gave really valuable input at strategic points in these projects. And we really appreciate you all as an important part of this scope community that helps make scope happen and helps these learning experiences be really valuable. I'll remind you quickly of the schedule for the day. We're almost done with the welcome bit, and we're going to pass it off to teams. We're going to have 2 groups of scope presentations from teams. We'll have a set of 6 presentations. We'll take a break to get some coffee and refreshments. We'll come back for the remaining 5. And for those of you who are in person, we'll go to a poster session in the Oval. After that, we'll have refreshments as well. Okay, a couple notes about the format for this session. If you're in person, this will feel like an in-person event, which is to say it'll feel weirdly familiar and unfamiliar at the same time, and we'll work it out together. So welcome to an in-person event. We're going to ask you to hold any questions that you have for the poster session. So maybe make a note, and then when you go out to the Oval, you can ask teams questions in that space. If you're joining us via live stream, hi, you will see slides in the active speaker. You know that by now because you've been looking at it. It can feel a little bit disconnected from the event if you're watching a live stream. So we created a feedback form. It's tinyurl.com/ScopeSummit2022. And as teams are presenting, we invite you to go to that link, give some feedback to teams, give encouragement to teams. Feel free to ask questions. It's not clear whether students will answer those questions because they're done after this. So, and we'll send them out and be free. But if there's something really compelling, we'll follow up with you. But please use that form. You also feel free to use that form if you're in the audience here as a way to engage with teams. And then for everybody, if it works better for you to engage with these slides and also with the program for Summit, we have those available via PDF link on the Scope Summit webpage. So that's olin.edu/events/scope-summit-2022. And if it's easier for you to engage with those things on your own devices, please find them there. Okay, so I'm going to pass it off to teams, which is the most exciting part of pretty much the whole year. And I want to, in this space, really honor the work that these students did. You all did incredible work this year, developing personally and professionally. You all blew us away with the way that you came together as teams and collaboratively worked on these really tough projects and stuck with it for the year. You also did things that created value. You got to endpoints that are really impressive and that are going to matter for your sponsors and for the world. And so as these teams come and they present their work, I ask you all to honor all of that work that they put in with a deep level of engagement and a whole lot of fun celebratory energy because we're really proud of them. Okay. And the first team that I'm going to welcome down is the Air Partners Aerodyne Scope Team 2022.
Thank you so much. Check, check.
Hello.
Hey, everybody. How's it going? Welcome. We're excited to be the first Scope team to present today, so we'll just jump right in. We are Olin's Aerial Scope team. Now, Aerial is a super fun acronym which stands for Accessible Environmental Epidemiology, Research, and Instrumentation for Analysis and Logging. And our team, thank you. And our team consists of Duncan, Michael, Thomas, Bryce, and Sky. And this year, we worked with Aerodyne Research and Air Partners, which are both air quality groups. But why do we care about air quality? Well, the two statistics on the screen should paint a picture for why we should care about air. First, we can see that air pollution has detrimental health effects. And we can also see from the second statistic that a lot of people live with unhealthy levels of air pollution. So, we want to understand the links between air quality and those health outcomes. And for that, we're going to need more data. Enter HAFTRAP. Here's another fun acronym. You guys ready? HAFTRAP stands for Home Air Filtration for Traffic-Related Air Pollution. And they aim to answer the question, how does home air filtration affect human health? Now, HAFTRAP is comprised of 3 of the 4 groups that you'll see in the Venn diagram behind me. Healthcare professionals, epidemiologists, and chemists and scientists. So they have a really strong understanding of human health and pollutant outcomes. But they need data, and that's where we come in. So Ariel provides engineering solutions to provide HAFTRAP air quality data. We've also worked with Aerodyne and Air Partners to further exploratory goals of the HAFTRAP study, the main one being instrument comparison. So here you see a breakdown of all of the instruments we've used throughout our project, ranging from low to high cost and complexity. And we hope through the data acquisition with these instruments to highlight their strengths and weaknesses, so that in the future, epidemiologists can look to these instruments and know whether or not they would be effective in a particular study. We've talked a little bit now about what our project is, so I'd like to break it down into our 3 main components. First, we integrated a suite of air quality instruments. Then we used that suite of air quality instruments to collect more than 50 full days of data over 4 deployments. And finally, we analyzed that data to generate our insights. I've used this word deployment a few times now, so I'm going to explain what that is. Over the course of our project, HAFTRAP assigned us 4 participant homes in Medford and Somerville and all along the I-93 corridor so that they could measure the effects of traffic-related air pollution. And this is what a typical deployment might look like. So I'll bring your attention first to the 2 modulaires, the outdoor and indoor modulaire. And these are our only air quality instruments that were not contained within our enclosure. And the reason that they're not included is because they are designed to be standalone and robust. But all of our other instruments, as you'll see later, we needed to integrate into our enclosure. Now you'll also note 4 sampling lines going into the enclosure, 2 from indoors and 2 from outdoors, 1 for particles and 1 for gases. And then finally note the HEPA air filter inside the home, which is turned on roughly half of each deployment so that we can measure its effects. So this is what our enclosure actually looked like. Aside from the modulaires, which as I mentioned earlier remain outside the enclosure, we integrated everything into our enclosure because as you can see, we were dealing with some pretty extreme weather conditions. To get a little more specific with how we designed our enclosure integration, there are 5 main points. First, our sampling line and implementation. It was designed so that we wouldn't have any particle or gas losses before that air got to our instruments. Next, we had to design our layout and rigging so everything was modular so that we could set up and tear down quickly on our deployments. We also had thermal design constraints to make sure that all of our instruments maintained their operating temperature ranges. We did waterproofing tests to make sure that our enclosure had no weak points so that none of our instruments would take any water damage. And finally, we implemented a software monitoring system so that we'd be able to monitor instrument health remotely and have peace of mind during deployments.
So we spent the whole first semester getting the system ready because we needed to rely on it to work continuously and unsupervised for 2 weeks at a time out in Somerville. And so that was our whole first semester. And then in the second semester, we actually went out and used it. And so we deployed it 4 times, and each of these deployments came with its own unique challenges and learnings. With that, we were able to collect a significant amount of data. And to give you a taste of what kind of data we were working with, we have just 1 instrument over just 1 day to show. So in the top, we have some of the indoor data, so indoor air quality. And on the outside, or on the bottom, we have the outdoor. And what you can notice is that indoor air has these things that spike up and fall off over a couple hours. And outdoors, we have these spikes that fall off after about 10 minutes. This makes sense because outdoor air can be exchanged with a change in the wind. And so this validated our data a little bit. But we looked a lot deeper and we gained a lot more insights because this is just a small slice of all of our data. So to summarize some of those, we looked at indoor versus outdoor exposure and found things like, whether you're exposed to more pollution indoors or outdoors. Near the interstates, it seems that indoors is better. We worked to identify pollution sources, such as cooking. We compared instruments to see what similar measurements from different instruments could say and whether they had the same stories to tell about the data. With regard to filtering, we looked at dissipation time, how long it takes a pollution event to decay back down to normal levels. And then finally, we dug deeper into filtering to see if there were more nuanced insights that we could garner from our data.
So what's next? Well, after all that, and after a huge amount of data collected, we still feel more data is necessary. And that means more deployments that last longer. And we'd hope with that increase of data, we'd be able to answer questions like, are the trends that we've seen between indoors and outdoors generalizable in the areas where we studied them and even other areas? And then finally, we hope to see Half-Trap continue to use the data that we have collected to find links between pollutants and human health. And in fact, we know that there will be a group on campus this summer working with our data. So that about wraps it up for our presentation today. We didn't really have the time to get into how we got to some of our insights or really the core of them. So if you have any questions about that or anything else, please come talk to us at the poster session. Leave us those tiny URL feedbacks too. Hi, Mom. And then lastly, we just have a few thank yous we'd like to share because this project really wouldn't have been possible without a whole heap of support from a lot of people, but we'd especially like to thank our friends and mentors at Aerodyne, Leah, John, and Phil, and at Air Partners in Olin, Scott, Alessandra, and Francesca. Thank you.
Hello. There we go. All right, well, welcome everyone. Thank you for being here. We'd like to share with you our Amazon Remote Manipulation System final presentation that we've been working on this year, AKA ARMS. We are this year's Amazon Robotics Scope team. My name is Maya.
I'm Colin.
And we're also joined by Katie, Sparsh, Christia, and Sander. And before we get into things, we'd like to thank a couple of people. First of all, our faculty advisor, Alessandra, our subject matter expert, Melinda, and our Amazon Robotics liaison, Greg. So thanks so much for your continued help and support through this project. So at the beginning of this year, our team was tasked with the development of a user experience to remotely control 2 robotic arms to manipulate packages on a table. The end vision being that an Amazon associate would be able to use one of our systems at any Amazon facility with ease remotely, virtually dropping in to solve problems that had stumped some automated system. Our user would be able to rely on an integrated vision system to be its eyes and the robotic arms to be their hands, no matter where our user is located physically. So our project had to deliver a user interface that was both easy to learn and to use, but also as powerful and effective as in-person direct manual control. So we think of our project as falling under this umbrella of robot-human co-working. We're going to get into that a little bit. So Amazon Robotics, and the name might give this away a little bit, is already a leader in the industry of using robots to automate tasks. As it stands today, Amazon delivers and processes approximately 20 million packages a day at their warehouses that are called fulfillment centers. In order to keep up with that amount of package traffic, robots are used to automate a lot of the tasks that handle them. And that's great because robots are really well suited to the fulfillment center settings. They're good at doing tasks that might be boring or repetitive, potentially tasks that are dangerous to humans over long periods of time, and they can do those tasks highly efficiently and very consistently. But that being said, they're not perfect. As we all know, robots are designed to do tasks as they're prescribed by the person who programmed them, and sometimes there are tasks that come up, they're outside that realm, and they just don't know what to do, as you can see here with this friendly pet Roomba who's caught chasing its tail between the legs of a chair. On the other hand, humans are really good at solving problems creatively. Here's an example of a father and son duo who are working smarter, not harder, to play a game of ball together. One of the reasons that humans are so good at creative problem solving is because they're really good at processing visual inputs. In other words, you're really good at looking at stuff. And you might be so good at looking at stuff that you actually take that for granted. For example, in this grid, you can pretty easily pick out the tiles that have traffic lights and which ones don't, just at a simple glance. But this is not a trivial task for a robot to do alone. And so that's the reason why we use tests like this to block bots online from wreaking havoc. So we know that humans are uniquely good at visual processing. We're creative. We can come up with creative solutions. And we're adaptable. We can find a solution to a problem even if we've never seen it before. So when we bring robots and humans together in this co-working that we're talking about, we kind of get the best of both worlds, each bringing what it's good at to the table. And this partnership has already been explored to some degree. So if you've ever used the self-checkout at a grocery store, then you've experienced robot-human co-working, or an amputee using a smart prosthetic that can open its hand, close its hand, or wave it based off of the user's inputs. But both of those examples, each of the partners has the benefit of being in proximity to one another. They share the same 3D space, and they get immediate feedback on each other's inputs or movements. So what Amazon Robotics asked us to explore made it so that we had to figure out what would happen to this co-working partnership when the coworkers they don't have the benefit of being close to one another. So in order for our user to command the robot, they need to provide an input. For example, move the arm up. And then that input has to travel across potentially a weak Wi-Fi signal. Data might need to be filtered or processed or queued, and then it needs to be received locally by the arm itself. And then the robot actually needs a little bit of time to move the arm physically through space. And now it's achieved a new arm position, and that arm position has to be sent back to the user somehow. And it gets sent over the same data tunnel with small delays at each step that might add up in sometimes variable ways. So all these small delays contribute to something called latency. When feedback is delayed, even by a small amount, it can severely impair your ability to operate a system, as we see here with this virtual reality ping pong example. If you've ever clicked on an application, waited a second, clicked on it again, and then had two of the same windows pop up, then you've also experienced the effects of latency. When we start sending inputs over the internet, this delay gets really bad really fast, and it can be very frustrating.
So we can't solve this latency problem, but we can develop strategies to make it less of an issue. This year, we developed 4 specific strategies. We help mitigate this latency problem. Together, they make remote control both intuitive and efficient. So one of the key problems with controlling a system remotely is trying to figure out where everything is without actually being there. To solve this problem, we created a virtual scene, which shows the positions of the arms in real time and allows the user to maneuver with the confidence that they won't run into anything. Another common problem with latent control is preventing overshoot. If we imagine a user trying to maneuver this gripper over this box, by the time they actually get the feedback that the gripper is over the box, the arm has probably gone way past because that signal took a long time to get back to them. We couldn't find a documented solution to this problem, so we developed what we call a virtual gripper, this green object, which the user moves without latency to where they want the arm to go, and the arm then follows. Because they don't have to worry about this delayed feedback, they can maneuver the arm incredibly precisely and go straight over the box. While this seems like a trivial feature, we found this is actually the single most important factor in determining success in picking up boxes. If you don't have a system like this, it's just impossible to deal with that latency and to actually reconcile your actions. Here's what this looks like in practice. We have the user moving this green virtual gripper, and the arm slowly moving to follow it. But since the user doesn't have to worry about how fast that arm is moving to prescribe their position, they can move this green virtual gripper very precisely, and then the arm just moves to follow it. So no amount of virtual views and virtual feeds can ever really make up for seeing what's in front of you. So in addition to all this, we include a live camera feed from the end of each arm showing the position of the box on the table. You can imagine this being used to read barcodes or figure out why an automated system messed up. So controlling 2 7 degrees of freedom robotic arms remotely is a fundamentally unintuitive task for humans. There are just way too many things going on for you to ever really understand what's happening. Trying to balance this problem between intuitive control and access to advanced features was an incredibly difficult task for our team, but one that eventually ended up creating a system that's both easy to use and very effective. So putting this all together, this is what our system looks like. We can see we have this virtual scene with the positions of the arms, and these virtual grippers that are commanding the arms where they should go. In the bottom corner, we have camera feeds, and they project simulated boxes onto the table. The entire thing is controlled by the user with an Xbox controller, giving them access to all of these advanced features. So here's the system of our video working. On the left, we have the real feed, the actual arm on the table. On the right, we have this simulated view. You can see that the two closely mirror each other, giving the user a really good idea of what's happening. You can also see that because the user is moving this green virtual gripper, they don't have to worry about the latency between the two, and they can maneuver incredibly precisely. So this year, we developed a prototype for Amazon that solves this latency problem. It works from anywhere, whether it be the local Starbucks or the back of a moving vehicle. In the future, Amazon plans to use this project internally to solve some more complex problems, and also work with future scope teams to develop it further. But why does this matter? We can imagine a fulfillment center of the future where humans and robots work together in unprecedented ways. We leave the boring and dangerous tasks for the robots, freeing up humans to do creative work and plan for future problems. When the robots mess up, the two can work together, each doing what they do best. This is great for Amazon because it means increased efficiency and reduced downtime in the robotic fleet. And it's also great for workers. Systems like this can lead to increased accessibility and flexibility, the ability to work remotely and across long distances, and the freedom to focus more on creative tasks. Together, systems like this can lead to incredible future for the fulfillment center ecosystem and unprecedented collaboration between humans and robots. We'll be doing a live demo out of the poster session, and we encourage you all to come and try out our system. It'll be a great time. Thank you.
Ready? Hello, we are the Blue Origin Scope team, and we're going to present you today a project that's the New Glenn avionics assembly tooling. So this is our team. Theo's on my left, I'm Argyris, this is Jonathan, and Matt's also on my left. No? There we go. So let's talk a little about Blue Origin. Most people know Blue Origin as just a rocket company. However, they classify themselves as just something a little more than that. They call themselves a space infrastructure company. Their mission is to build the road to space so our kids can build the future, and they have multiple projects that work along that line. So some of these projects are like the project you're going to see behind me, like orbital and suborbital vehicles, space stations, as well as lunar landers. Our project is specifically for the New Glenn program, so it's up left on the left, and it's the orbital rocket of Blue Origin. So what you see back here on my screen is a standard military spec connector. This is used across the aerospace industry. Is that a plane? Is that a satellite? Is that a rocket? So these connectors just connect different sensors and avionics boxes with each other, and they have tightened features to make sure that they don't disengage during the vibrations of flight. They have to be torqued at a very specific torque, and that's allocated by our specifications. And you really don't want these to get loose. You can get explosions or worse things. So there is a currently industry standard solution to do that. What you see here, Jonathan also is holding one, is like a Glenn Air connector, Glenn Air tool. So pretty much you get the strap around the connector, and then you use it in conjunction with a regular torque wrench, and then you tighten the connector. Simple, right? 1, 2, 3 hands, maybe a fourth one down here. But you can get away with it, right? You need 2, 3 people, you're going to get it work. Well, the problem is this. So when we talk about aerospace, we don't talk about like connectors here and there. You have to use this tool to connect the connector down here. So I think you start getting what the problem is. So Blue Origin knew they're going to face that problem. They just didn't know exactly how to solve it. So this is where our team comes in. So like, why do we care? Why does Blue Origin care? The thing is that the current process they have is firstly takes way too long, and also, as you saw, cannot always reach the connector. Blue Origin is building rapidly reusable vehicles. This means that the rocket needs to launch, land, get a technician in there, double check that all connectors are right, and then launch again. So you need something that can do this process very quickly. In addition to that, you have to make sure it's reliable. You have to know that when I go in there and tighten the connector, this is exactly the torque I'm applying, and I can trust this tool. So our team got to work.
To approach this problem, we knew we had to work closely with our users, the engineers and technicians at Blue Origin. We implemented an iterative design process, starting with researching existing technology, working heavily on our design and prototyping, and implementing feedback along the whole time. To start out, we gathered some tools, a lot of tools, and evaluated them on their features and what made them good at what they do. We wanted to know how we can leverage these features and ideas to create new ones and how we can apply them to our tool to make sure that our tool is easy to use and reliable. Next, we focused on our design and prototyping process, which was very not linear. Blue Origin knew that they had a problem and they didn't know exactly how they wanted it to be solved. So we got the chance to co-design with them to figure out what was important to them and how we could accomplish this within 2 semesters. In the end, we were able to synthesize all our ideas and bring them down to a coherent solution. Throughout the whole process, it was important that we got feedback, whether this was from our Zoom sessions, from our packages going back and forth to Blue Origin, from our trip to Blue Origin last semester. It was very important that we got feedback throughout the whole process. You can see in the center photo above our team presenting our prototypes to our liaisons at Blue Origin's headquarters in Seattle. In the end, we produced 2 physical tools, a primary and secondary solution that are en route to Blue Origin right now. There's a team of engineers there eagerly and excitedly waiting for our tools to evaluate them and identify if they'll be integrated into the new Glen assembly procedure right away, or if they'll be further iterated on and integrated later this year. Blue Origin is extremely excited that our tool will make the mil-spec connector assembly process easier, faster, and more reliable. I want to take the time to thank everyone who was involved in making this possible, especially our liaison, David, and our Olin scope advisor, Jessica Townsend. If you have any questions, please feel free to stop by our booth at the poster session later today, and thank you.
I might need that. Hi, everyone. My name is Megan, and on behalf of my teammates Melissa, Lily, Jane, and Mia, I'm excited to share with you our project in partnership with Mbari and the Dassault Foundation, designing deep-sea play experiences. Our oceans are teeming with life, from the colorful reefs near the surface to the thermal vents near the seafloor. You might be familiar with creatures such as sharks, manta rays, and dolphins, but there are so many other forms of life in the deep sea that you may have never heard of, like the Tomopterus, or gossamer worm, which dances through the midwater with the rhythmic paddling of its many swimming legs. These fascinating creatures don't have the same visibility in general media, and you might never even hear about them unless you're actively looking for information about them. Imagine if you knew what a gossamer worm was before Scope Summit. Which leads us to the question, What if young children learned about the wonders of the deep sea through their everyday play? And this is where our team comes in. MBARI, or the Monterey Bay Aquarium Research Institute, is a research institute affiliated with, yet separate from the Monterey Bay Aquarium in California. MBARI hopes to leverage their insights into the deep sea to foster a mindset in ocean conservation in children from a young age. By evaluating MBARI's goals and values, our team determined that curiosity and familiarity could be the foundation in supporting these long-term outcomes. With generous support from the Dassault Foundation and in partnership with MBARI, our team designed play experiences that foster curiosity about and familiarity with the deep sea through play in children 3 to 6 years old. Over the past 2 semesters, we developed play experiences that were novel, impactful, educational, and fun. Our extensive market research supported our ideation. We then took those ideas into prototyping, which we validated through interviews with parents and children over the course of the year. For our market research, we looked into existing toy trends, developmental stages in children, and already existing educational play experiences. By analyzing research papers and other sources, we learned a lot of things. One thing we learned was that play that promotes autonomy and agency reassures children of their ability to affect change. If we want children to feel empowered to make a difference in the world around them and with ocean conservation, our toys need to encourage that empowerment. Another thing we learned was that play that builds relational value is most effective in changing mindsets. Therefore, our toys need to spark a relational connection in order to make an impact on the children that play with them. As we were developing our foundational knowledge, we also had several ideation sessions where we generated ideas for play experiences around specific deep sea creatures, general interactions, and overall themes. Pictured here are artifacts from an ideation session around the gossamer worm's behavior and appearance. After generating several of these ideas, we mapped our ideas on frameworks to help us understand where our ideas lie in the space of play. What you can see above me is a set of 2x2 axes where we put some of our ideas against how imaginative we envisioned the play would be, against how much physical energy we might imagine a child would use in interacting with our experience. Based on our research, we wanted to lean toward the right hemisphere because we were focused on giving that empowerment, that creativity, and overall ownership. But we didn't decide to restrict ourselves on the amount of physical energy required, and you'll see that our final results show a wide range of active engagement. Over the course of 2 to 3 week cycles, our team prototyped several of our ideas to bring them to life. We utilized our expertise in materials testing, CAD, sewing, and other rapid prototyping skills in order to fully realize these ideas in the physical space. We even invited children and their families to playtest our prototypes, putting our ideas to the test in front of our most important stakeholders. Playtesting with children enabled us to get real-time feedback about design considerations and the feasibility of our own play experiences. From these interviews, we gathered new insights that helped direct our toy design. As a result, we designed 4 toys that provide engaging experiences while introducing young children to the deep sea. For our most promising ideas, we created detailed prototypes to send to MBARI using tools like SolidWorks to develop detailed representations. We also designed a central ecosystem and digital platform to help unify our ideas, expand the reach and possibilities for children to interact with the deep sea, and to promote resiliency in the market. These toys and digital platform contribute to growing curiosity about and familiarity with the deep sea. And we believe that these toys provide novel play experiences that are backed by MBARI's breakthrough research. We have organized our ideas and our recommendations in a detailed design book to MBARI, which includes our research, design considerations, and recommendations. We have handed this design book off to MBARI along with specific suggestions for next steps for each toy so that MBARI can outsource manufacturing and licensing to bring these experiences to market. We believe that our ecosystem, our collection of toys, and our digital platform provide the foundation for a larger ecosystem of deep sea play experiences in the future. And we have communicated our findings in our design book to promote expansion and resiliency in the toy market. We wanted to take a moment to thank the people that helped make this project possible, our Mbari liaisons, Kakani, Yost, and Paul, our Dassault Foundation liaison, Debbie, our subject matter experts, Deb, John, and Ben, as well as our scope advisors, Scott, Jason, and Jessica. We're so grateful for all of your advice and support throughout the year. Our oceans are an incredible part of the world we live in, and we believe that our play experiences will spark curiosity in the deep sea for generations to come. Thank you very much.
Hello, hello. Ooh, hello. Howdy. Oh, lovely seeing all your faces. Wow. Hello, everyone. My name is Corey, and welcome to our presentation, Catalyzing the Transition to Electric Vehicles, and we are the Ford Scope team. A little bit about who we are. My name is Corey, and these are my wonderful teammates, Abigail, Ruby, Ria, and Audrey. We would like to thank our 2 advisors, Scott and Jessica, as well as our 3 Ford liaisons, Christina, Trevor, and Brad, for their endless support and trust that they gave us in this project. A little bit about our project. So we spent the year thinking and working on how to catalyze the transition to electric vehicles. We did this by exploring barriers of EV adoption and uncovering ways to accelerate the societal transition to EVs. One of our guiding questions throughout this project was, how might we encourage Ford's customers today to become BEV adopters in the future? Why does this matter, though? Well, for one, Ford has recently launched a new business unit devoted to electric vehicles. Ford is also looking to transition to EV to ensure a clean, sustainable, and more livable future, acknowledging that fossil fuels are not going to be sustainable in the long run. So how did we do that exactly? Well, we did it using a human-centered design process. We started the year off by doing a little bit of initial and background research into the known barriers of EV adoption. We then conducted 2 rounds of interviews, talking to people. From there, we developed 6 insights, 3 areas of opportunity, that we used for the second half of the project that we dove into. And in the second half of the project, we conducted 2 rounds of co-designs where we physically put things in front of people to get their thoughts and feelings on. And from there, we generated 6 key recommendations for Ford. And we're going to talk a little bit about everything of all of this during this presentation. So during the explore phase, we did some initial research into what are the known barriers of adoption to EV. As well as what are some of the key differences between traditional combustion vehicles and electric vehicles. We also attended an EV car show here in Wellesley, right down the street, where we got to familiarize ourselves with current EV owners on their experience of owning EVs and why exactly they chose EVs for their lifestyle. So during the understanding phase, we took our learnings from the initial research, created an interview plan for our first interview, and then implemented an iterative design process to update our guiding questions, reassess our biases, and reevaluate the trajectory and direction of the project as a whole. We synthesized the learnings from each design, from each set of interviews, and generated new direction that we took every step of the way. So after the 2 rounds of interviews we did in the first half of the project, we created 6 insights, and we're happy to share 2 of those with you today. Vehicles are an accepted part of my life, but EVs don't fit that model. I wish EVs worked the way my current car does. People are pretty comfortable with what a combustion vehicle can do and how they can use it, but people have this incomplete idea or model of what EVs can do and how that might fit in their lives. EVs have not gained my trust. My external trusted sources don't have a clear stance on EVs. People have a direct sphere of influence that they look to when they're making large purchasing decisions like buying a new car. So there just isn't enough people who own EVs for there to be enough for everyone to have someone close to that they can reach out to for help and answering questions on whether or not EV is a right fit for their lifestyle. From these insights, we generated 3 areas of opportunity that we use and later dove into in the second half of the project. How might we build trust in the end-to-end experience in owning an EV? How might we bring familiarity into a space that feels novel? And how might we emphasize the freedom that is gained rather than lost when buying an EV? By the end of the project, we created 8 low-fidelity prototypes, conducted 14 co-designs, and generated 6 recommendations to Ford. We used our learnings from the 2 rounds of interviews in the first half, our 6 insights, our 3 areas of opportunity, as well as our learnings from our 2 co-designs. We took that information, we iterated on it, we filtered it, and we distilled it down to 6 recommendations that we gave to Ford. We're happy to share with you 2 of those today. Integrate charging stations into people's existing routines. Charging is seen as an unfortunate byproduct of owning an EV, but by integrating it into people's routines, it can become a benefit. One of the things that affects this perception is the explicit lack of perception of the existing infrastructure that we think affects this greatly. Invest in ways for people to experience EVs firsthand. Lived experiences are more efficient at building and shifting mental models than information or non-physical stimulus. People can do their own research, they can talk to their friends and family, but one of the most efficient ways at shifting a mental model is for them to experience it themselves firsthand. And that concludes our presentation. We'd like to thank you for coming here today and joining us, and I look forward to seeing you at our poster session.
All right, so we've reached the halfway point in our presentations, and we're going to take a quick break. We're going to take 10 minutes, and I totally failed to bring my clock time. It's 2:01. Wow, we're 1 minute behind. Okay, so please come back by 2:10. We're going to start our presentations again with GE Healthcare. We'll look forward to seeing you in a few minutes. There's some coffee and refreshments right outside the door here, so please go help yourselves. my life.
Good. Can you give me that? Check, check. Sound check. Sound check. Sound check this one. That's better, yeah? Can you hear me in the back? That's better. There it is. We have a secret 2.5-minute agenda item to thank our outgoing director, Scott Hersey. So in the summer of 2019, Scott took over directorship from Alicia Sarang-Skaminski, who crafted the SCOPE program as it's currently shaped. And I'd like to share with you about the growth and changes that have happened in the program since then. It's worth noting that during this time, we transitioned the program. There was a pandemic during that time, maybe you've heard. And in that time, we transitioned the program from in-person to remote to hybrid and back again. And Scott, during that whole time, your spirit of leadership never wavered. And Scott's spirit of leadership really puts care for his teammates, that's us, and the SCOPE community at the forefront of our operations. SCOPE is one of 3 capstones on our campus, and it's one of 2 that Scott's involved in. And along with Ben Linder and Scott Harris, the other Scott, over the last few years, they have worked to improve both the fairness of the process and the efficacy of matching students to those 3 capstones. On the project side, both students and our sponsors know how hard it is to find project spaces that are both provide value to the company, but also provide student teams with sufficient autonomy to meet the educational goals of the program. So together, Ruth and Scott work incredibly hard on the global puzzle that it is assembling a complement of companies that assemble our program that match with the student skills that we have and include collaborations that involve the social impact spaces that many of our students are most motivated to work in. The collaboration between Ruth and Scott is one example of what I think is his biggest and most lasting impact on the SCOPE program, which is the evolution of the faculty and staff partnership and the leadership team. So Jessica McCarthy's title change, where are you? Oh, hi, Jessica. Jessica McCarthy's title changed this year to include co-director of the SCOPE program. And that is an accurate assessment that operations on this campus rely equally on both faculty and staff to make them run. And that faculty and staff partnership, so SCOPE is now serving as a model for this faculty and staff partnership on their campus. And I think that these partnerships are critical for Olin to make the changes that it wants to make in the landscape of engineering education. And Scott led us into those partnerships. So Scott, thanks. And as a token of our appreciation, we have for you, as a token of our appreciation for that good work, but also as a token of gratitude for the talent you have for bringing turkey metaphors into advice and casual conversation, we have for your family a Mass Audubon membership. And we also have a turkey-themed thank you that we'll be making at the poster session. So Scott, we're proud to work with you, and thank you for your 3 years of leadership.
Thanks for that. I'll share some related words after all the students are done, but thank you all so much. Okay, our next team, GE Healthcare, come on down.
Thank you.
Hi, everyone. We're the GE Healthcare Scope team, and we are so excited to be sharing our presentation with you today. I'm Alex. My teammates are Riley, Colin, Justin, Emma, and Annie. And let's get started. First, I'd like to quickly introduce you to our sponsor, GE Healthcare. Among other things, they make large medical equipment, like MRI machines. They also package, deliver, and install these machines at the hospitals that use them. Today, I'd like to zoom in on one small part of that process, shipping. Due to supply chain constraints, GE has explored alternative shipping methods, specifically for us, rail transit. Now, the way that a box bounces around inside a rail car is very different from the way it might bounce around inside an airplane or a truck. So the problem statement that we were brought in to solve is that medical equipment is being damaged in transit before reaching its final destination. Current packaging just isn't designed for the loads that it will see in rail transit. So our question was, how can we build confidence that packaging will be robust enough to handle tough shipping environments? Fortunately, GE is not the only company that has seen this problem in the past. So there is an industry standard way to address these problems. The way most people answer these problems is by using inclined impact testers. Here are a few options that you can buy on the internet right now. Basically what they do is you put a box that you hope doesn't break on a sled, let it go, and if it doesn't break, you're pretty much good to go. The problem is GE had a specific set of requirements that was not met by these testers. These testers, even though they may not look like it, are pretty small, smaller than GE's needs. They don't include a whole lot of sensing for data collection. They also don't output the test results in a meaningful or useful way. So that's where we come in. We built GE a custom inclined impact tester that addresses all of the problems I just talked about. It includes an integrated sensor suite, involved a lot of mechanical design to make sure we hit GE's velocity requirements, and includes a user interface and software stack that outputs reports that can be shared within GE for rapid iteration on packaging. Now I'd like to talk a little bit about all of the components that went into making this happen. First, there's a whole mechanical system. There's the track, which is 22 feet long, weighs about 1,000 pounds, and needs to support packages up to 2,000 pounds. So this thing was really big, and I'll get into some of the challenges that I introduced later. There's also the carriage that slides down the track, the pump, the enclosure, a whole bunch of enclosures all over the system. There's also an electrical-mechanical system that's responsible for moving these giant packages and this giant track into the places that they need to be to run a test. There's a whole sensor suite involved that senses velocity, temperature, humidity, and a number of other environmental conditions that are important to log during these tests. And then to control it all, there's a software suite, which is the whole tester is controlled via like a Windows Surface tablet running a custom software stack that we developed ourselves. Now I'd like to walk you through a little bit about our process. We started the year in September with a set of requirements. These requirements took the form of nationally recognized standards as well as some additional requirements from GE. These requirements dictate how fast the package needs to be moving when it crashes into the backstop, what the temperature needs to be, what the humidity needs to be, how many different things you need to measure, how accurately you need to measure them, pages and pages of requirements. And from there, we were able to start designing. Once we had our initial designs, we were able to crank out some small-scale prototypes in a matter of months. On the left, you can see sort of a smaller version of the impact tester we ultimately built. And these prototypes serve two main goals. First, they helped us validate some of the assumptions that we made in our larger system design so that we could make small adjustments in the bigger final design of our project. And secondly, they allowed us to parallelize electrical and mechanical work. Building the full-scale impact tester took the entire year mechanically, and so for us to be able to do electrical development on a smaller scale prototype was enormous in unlocking the productivity of our electrical and software teams. Once we built our prototypes, we had to build some confidence that they would actually work at scale. Putting 2,000 pounds on a track is a much bigger deal than running tests with the prototypes that we had. We needed to be confident that the track wouldn't break. So we did a lot of really rigorous mechanical design, including finite element analysis, to make sure that this track wouldn't break under full load. Once we had built that confidence, we got to fabricate it. This was a big challenge for our team. This is just a huge, huge project that Olin's shop hasn't really seen before. So we had to get really creative, work with our shop staff, rely on a lot of outside resources to make this happen, and we're really proud that we were able to build what we were able to build. Finally, after we had built it, it was time for integration and testing. We had to put all the sensors on, make sure the sensors worked, make sure the electromechanical systems worked, the track moved as we expected, and that's sort of where we wrapped up our project. Now I'd like to walk through a little bit of a few of the challenges that we faced throughout this process. We faced a good number of challenges, and we're pretty proud of the stuff that we were able to overcome during this project. First was just the sheer scale. I mentioned this a few times, but the track was 22 feet long and used to support packages up to 2,000 pounds, moving 8 miles an hour. 2,000 pounds is like the weight of a small car. So we were basically building like a roller coaster, which is not something that we got to do previously at Olin. So it was a really, really interesting project in that sense. Next was division of labor. You may have noticed earlier just the number of different subsystems that had to come together to make this all happen. And frankly, it was out of scope for us to do all of them at Olin. So we had to work really closely with GE to divide up ownership of these different subsystems. For example, the backstop needs to stop that 2,000-pound load moving at 8 miles an hour. And building such a thing at Olin was going to be nearly impossible, especially on top of everything else you had to build. So we had to work closely with GE to figure out what they could build with their sort of larger fabrication house outside of Olin. Dividing labor up like this had some pretty big implications. We didn't have a fully integrated end of state shippable impact tester at Olin to test with. So we had to get creative with how we tested. As you can see here, we put our track on a hill. And that's how we were able to actually validate a lot of our designs through this type of hill testing and other sort of creative solutions. Another big challenge we faced was integrating pre-built parts. In order to pull this thing together in 8 months, we pulled in components from a variety of different industries. For example, on the right, you can see a hydraulic lift that is mostly sold to people who are building dump trucks. The interfaces to these sort of pre-built parts aren't very well defined, or they're well defined, but they're not super standardized. So in order to get this hydraulic dump truck lift to work with our tablet, we had to build a lot of custom circuitry, which you can see here. And so getting all these components from a whole array of different industries to work with our setup and our software stack required a lot of electrical and software work. Finally, I'd just like to recap what we learned through this project. We learned some really important requirements-driven design. We got a lot of systems integration experience. And we also did a lot of design for manufacturing and assembly. Some next steps for GE include on-site assembly at GE. The tester is actually in a truck on the way to Wisconsin right now. Full-scale testing at their lab, and iteration and reproduction so that GE can do these kinds of tests outside of just the one lab that we're shipping to. I'd just like to thank our sponsors again so much. Thank you, Jason. Thanks to the rest of the team. And we are really excited to see you at the poster session later this afternoon.
Hello. Hi, everyone. We are the Johnson & Johnson Scope team, and we're really excited to talk to you today about what we did for the past year, which was end effector exploration and design for a laparoscopic robotic surgery. And taking a step back, I know that that's a lot of words and a lot of really technical words, and when we started the project, we had to do a lot of research to understand a lot of this, and we're hoping to break that down for you today. But before we do that, I would like to introduce our team: David, Bennett, Mahima, Navi, or me, Sharon, our advisor, Alessandro Frizocco, and a huge thank you to our liaisons at Johnson & Johnson, Quinn, Tracy, and Chuck, and a special thank you to Lucas, Debbie, Matt, and the Blood Farm for providing us with materials, which we'll go into in a little bit. So for the past year, we focused on the thoracic cavity. What is the thoracic cavity? It's a hollow space within the body enclosed by the ribs. In this space, if there is diseased tissue in the lungs, you can actually remove a portion of the lung in order to perform a life-saving procedure called a lobectomy. And there are 18,603 thoracic procedures for lung cancer alone in 2014. Frequently, with lung cancer, there might be a tumor in one of the lobes of the lungs, and performing a lobectomy is a life-saving procedure for these patients. Roughly 20% of lobectomies are robotic-assisted thoracic surgeries, also known as RATs. The goal of RATs is to improve long-term patient outcomes, speed up healing times, and increasing repeatability through a standardized procedure. In the lobectomy process, in order to remove a lobe, all the vessels that connect to that lobe to other lobes in the lungs need to be sealed and cut. And this process is called the vessel separation process. The first step in this is identifying the target vessels. The second step is to separate the target vessels from surrounding tissue, then creating a physical distance between this vessel and any surrounding tissue. Then the space needs to be maintained for transection or cutting and sealing. And then lastly, any bleeding needs to be cleaned up. Ideally, there is no bleeding as a part of this procedure, but sometimes due to the tight constraints of the thoracic cavity, this may occur. Our scope specifically is the vessel isolation procedure, where physical space between the vessel and surrounding tissue needs to be created, and that space needs to be maintained for the vessel to be transected or cut and sealed. Vessel isolation is the creation and maintenance of space between a targeted vessel and its surrounding tissue. Our goal for the past year has been end effector design for vessel isolation. But what is an end effector? So say my arm is a robotic arm, the end effector is the hand portion of the robotic arm. And we did this by designing a specialized vessel isolation tool for Johnson & Johnson's robotic surgery platform and explored alternative solutions that have potential to improve patient outcomes. We started this process by researching user needs and existing tooling. We wanted to understand what surgeons use today to do this process. And currently, that seems to be strings and the surgical equivalent of tweezers. Then we moved into identifying priorities and decision criteria for building a tool such as this. Simultaneously, we considered sensory inputs that could enhance robotic-assisted thoracic surgery, or RATs. Then we moved into prototyping our designs and exploring force sensing and material properties of the lungs to figure out what information might be useful for surgeons. And lastly, we tested our solutions in a porcine or pork or pig lung lab. And thank you to Blood Farm for providing us with these materials. And then we did this process again and again, which resulted in 2 end effector solutions. On the left here, you can see our final linked robot design. And we call this linked because on the bottom, you can see a bunch of tiny links, which are embedded in a silicon sleeve, as you can see above that, to allow for a curling motion, which we'll show you in a minute. The diameter of this tool was 9 millimeters. That is really small. That is also to scale for what is required in this procedure. On the right, you can see our final soft robotic design. In our soft robotic design, there is no mechanical structure inside. Instead, it inflates similar to a balloon and results in the curling motion that you can see. Both of these solutions seek the path of least resistance. We integrated the linked design with Johnson & Johnson's robotic platform and tested in sample lung tissue. Here you can see the linked design and benchtop testing. You can see if you pull one string or the other string, it curls. But if you pull both of the strings, it becomes rigid, which can also be very useful as a part of this procedure. When embedded in a silicone sleeve and integrated with Johnson & Johnson's robotic platform, you can see here on the right, it can curl around a syringe and have some grip due to the silicone's sticky nature. And then also on the left, you can see that due to the Johnson & Johnson robotic platform's rotational motion, the curling can then be rotated. From the force sensing side, we know that more sensors means more information for the surgeon. For sensing to be useful, we realize that one of the following must occur. The graphics that are displayed to the surgeon must be simple and integrated with a camera view of the vessel. We want surgeons to be able to see what's going on in the surgical area as well as any force feedback. Or haptic feedback or touch feedback should be implemented since displays can create distractions. By pursuing 20 prototypes in 3 key areas, we were able to propose 3 spaces of recommendation to Johnson & Johnson. We proposed to develop link mechanisms further by iterating on the tool to move around in more directions. We realized that by utilizing the curling motion of the tool and the rotational motion of the robotic platform, it was a bit cumbersome to rotate and then curl, so we propose allowing the tool to move in more directions. Additionally, we propose testing the efficiency of this tool at smaller diameters. Although right now it is at a 9 millimeter diameter, if the tool is able to become smaller, it can fit between tighter wound vessels. Additionally, we recommend pursuing force sensing if data is easily understandable, and we propose that the UI shouldn't distract from the surgical video feed. And lastly, we recommend pursuing soft robotic designs if the control setup includes pneumatic or air control, and each tool is quality tested for leaks before use. This was a failure mode that we encountered when prototyping. Thank you so much for your time and your attention, and thank you to Johnson & Johnson for a great scope year. And if you would like to come to our booth, you can see a lot of our prototypes and play around with them as well. Thank you.
All right. Hi, everyone. My name is Maya, and I'm super excited to be with you all today to chat about our Team Scope project. Alongside my wonderful teammates, Elias, Mal, and Manu, we had the pleasure of working with Pfizer to use blockchain technology in order to model their clinical supply chains. So Pfizer does a whole number of things. You've probably heard of them, especially in the last couple of years. But one thing that they do is they work on rare diseases. So they're specifically looking at treatments for rare diseases and clinical trials in which they can test those treatments. And we specifically this year looked at the supply chains for creating and distributing those treatments. So what is a rare disease and why do these trials matter? Well, a rare disease is a disease that affects fewer than 1 in every 200,000 Americans, and about 30 million people in America, or 10% of the United States population, has a rare disease. So that's equivalent to about the number of people who are diagnosed in this country with diabetes. Tragically, most rare diseases are life-threatening and have no treatments. So clinical trials like the ones that Pfizer runs are often patients' last hope. There are a number of problems in rare disease supply chains that don't appear in traditional supply chains. First, they're really complicated multi-party processes. So there are a ton of different actors throughout the supply chain that all have to have really accurate information. Second, right now, information is basically exchanged via email, physical documents, and an array of miscellaneous systems. Especially in a healthcare context, there are major concerns around security and privacy. Lastly, there's a lack of real-time tracking throughout the supply chain. Given the small patient population, it's essential to reduce excess drugs. And these drugs have very narrow temperature ranges, and as soon as they fall out of compliance, Pfizer needs to know about it. Unfortunately, currently, this process is extremely slow. This all matters because in the case of gene therapies for rare diseases, any level of risk in supply chains is unacceptable, since errors can cost patients their lives and jeopardize the integrity of entire clinical trials. That's where our project comes in. Our project aims to use blockchain technology in order to mitigate the problems of existing rare disease supply chains. Before you think only of Bitcoin, allow us to rewrite the narrative a little bit. We are using the technology that underlies cryptocurrencies, called blockchains, in the context of those supply chains that we just talked about. You can think of a blockchain as a super secure list that records interactions between actors. For example, we can follow the life of drug X. Each event that drug X goes through is recorded in that blockchain list. First, Pfizer requests drug X, then a distributor packages and labels drug X, then a distributor updates drug X's status to be en route, and finally, a clinical site administers drug X. This system is different than what is going on right now because blockchain allows Pfizer and everyone else in the supply chain ecosystem to see exactly when and where these events occurred, which is essential for audits and other regulatory processes. You can think of this like when you're online shopping and you're waiting for your package and you're excitedly watching your online update statuses. That's the joys of track and trace technology, and that is what blockchain is providing for Pfizer. So Pfizer's actually been looking at this space for a little while. but they've kind of come across a few big questions that they hope we could help them answer. The first thing they wanted to know is, can we use blockchain to mitigate the problems of rare disease supply chains? Essentially, is blockchain feasible to solve these problems? Then they wanted to know, can blockchain work at the scale that we need? Since this is a pretty complex problem, while these questions may sound kind of foundational, they're actually, they took our team a year to answer, so they're not that easy. Plus, since this space is pretty new to Pfizer, or at least there aren't a ton of people working on it right now, they asked us to both look at the administrative overhead and the technical accomplishments of our project. We bucketed our project into 4 main groups: understanding, simulating, automating, and analyzing, which corresponded to those 2 questions we just talked about. In understanding, we tried to comprehend what supply chains look like right now. In simulating, we used blockchain to generate a model of a simplified rare disease supply chain. In automating, we wrote a bunch of code that made tons and tons of those models. And then in analyzing, we looked at the differences and figured out what we could learn and what we could tell Pfizer about how they may or may not be able to use this technology. In understanding, we spent a lot of time just grasping what rare disease supply chains look like, and we were especially concerned with the messages that actors were sending. For example, drug X packaged and labeled and drug X en route are messages and information that are exchanged in the supply chain, and those became crucial for us to understand in our project. After that, we used blockchain technology to simulate a rare disease supply chain. So basically, we wrote a bunch of code and modeled a really simple version of what the supply chain might look like. As you can see, those messages, like drug X administered and drug X en route, became entries in that blockchain list. This simulating portion was extremely important because it allowed us to see that all of the technical pieces could work together, essentially, that this was feasible, that we can use blockchain technology to simulate current supply chains and solve the problems of rare diseases, or of rare disease supply chains, excuse me. After that, we worked on that second question around scalability. Essentially, we built a tool that acts like a conveyor belt. So you can put in a variety of things about the supply chain that you want to produce, so like organizations, relationships, just various features, and our system will produce for you a blockchain system that models that supply chain. Once we did that, we came up with some tests and ways to evaluate those systems, and some worked better than others. For example, if one of our models had a supply chain that could only handle 1 interaction between organizations in 1 second, that wouldn't be very useful to the tens of thousands of people who are working on Pfizer supply chains every moment. So we realized that it would be really essential to understand how the speed of our blockchain system corresponded to the number of people in it, or its size. Fortunately for us, all of the speeds and sizes that we tested were useful to Pfizer, so we never got below a speed threshold that Pfizer couldn't use. So that was awesome. We essentially learned that, in fact, this system is scalable to Pfizer's needs. But we didn't actually have all of the technology to simulate the millions and millions of transactions that exist on an enterprise-level supply chain monitoring system. So Pfizer is picking this up for us and doing some more robust testing in their enterprise scale environments to ensure that this is actually scalable and that we can be 100% confident in these conclusions. Essentially, we've shown that blockchain can successfully track and trace a gene therapy product through deployment. We've seen that blockchain can verifiably and securely meet Pfizer's requirements and can scale to the size that they need. Most importantly, we learned that there is a path forward using blockchain for Pfizer's clinical supply chain needs. Using our tool, Pfizer can now quickly and easily simulate any blockchain system or any supply chain scenario and understand how it will behave in the real world. We've essentially handed them a set of knobs where they can turn up or down the number of organizations or turn up or down the number of relationships between people and see exactly how a blockchain system could be spun up with those constraints and how it will behave if they put it into the world. This project would not have been possible without a whole bunch of folks who were just so instrumental in making it happen. So thank you to all of the folks on this slide. And we want to also acknowledge that this was a deeply technical project that we've simplified a lot to get into this presentation for you. So if you have questions or want to learn more or are interested in getting into the weeds with us, we'd love for you to swing by our poster session. Thank you very much.
Hi, we are the 2021-2022 Santos Volpe Scope team. Today we will be talking about Rurina, a mobile app for standardized and efficient crash reporting. This project was made possible with the U.S. Department of Transportation Volpe Center and Santos Family Foundation. Our team is Shreya, Jack, Casey, and myself, Kristen. Every year, thousands of lives are lost due to traffic crashes. Public policy experts and city planners are tasked with making infrastructure decisions that require high-quality data and high quantity of data. However, the current system for collecting reports is not efficient. When a reporter goes to the crash site, they have to fill out paper reports that require manual data capture. When they get back to the office, they have to transfer the paper report, often to a digital format. During this process, data is often lost, and there's a lack of standardization in the responses and questions asked. When it gets to the public policy experts and city planners' hands, the data is inconsistent, and therefore they make uninformed infrastructure decisions. To solve the aforementioned problems, we introduced Rurina, a cross-platform application with standardized and efficient crash reporting. This is the third year of development for Rurina, and over the past 3 years, we have developed the app so it has an easy-to-use interface, intelligent tools, and it uses standardized questions developed by experts to collect the minimum amount of data required from a crash site. Our contributions to this team are the app redesign to make it more friendly and intuitive for users, and to restructure the code so that way it's more sustainable for future developers. Second, we implemented 3 high-value features: user input validation, autofill features, and a crash diagram tool that help generate high-quality data and provide important context to the crash. And finally, we ran user testing sessions with 2 tribal jurisdictions for 3 weeks. At the end of each session, we gained key insights to help guide the future of the project. With our app redesign, we focused on redesigning the user interface. As you can see in the top picture, there's a lot of colors, and they were not as easy to read. So we focused on making it have a more cohesive design and a pleasing aesthetic for the users. While we also making these changes, we simplified the code so it has higher quality and is more sustainable for the future. Our first high-value feature is user input validation. The benefit of this feature is that it helps provide high-quality data for the users. As you can see, when there is an error, there has a red box that illuminates. And every time a user interacts with a question, it automatically checks the response. If the user has not interacted with the question or the answer is valid, there will be no visual indication. Our second set of high-value features are our autofill features. Autofill features allow users to collect data faster, and it reduces the human errors in typing. We currently have 3 autofill features: license plate scanning, driver's license scanning, and GPS location. Each of these features populate the corresponding questions so that the user does not have to type. Our third set of high-value features is the crash diagram tool. The crash diagram tool is beneficial to users because it allows people looking at the report after the fact to see all the events of the crash, and it allows people to analyze all the possible elements that could have caused the crash. Our crash diagram tool is a free draw diagram. A free draw diagram allows you to show all the steps of the crash so that way you can see how it evolved. In our user testing sessions, we tested with the Shinnecock Nation in Trinidad Rancheria. Last year's team determined that the target users for Rurina would be tribal jurisdictions with the guidance of our liaisons. The tribal jurisdictions offer a unique perspective because they are often an underserved population with current crash reporting. We ran 3-week sessions with each of the users, and we had 3 check-in sessions and to learn about what they thought of the app. And between the sessions, they tested with scenarios that we provided them, previous crash reports that they had, or crashes that occurred during the time. During our user testing, we had 3 main limitations. 1, users needed to have Android tablets, and as a result, this limited the amount of people that we could test with. Second, all of our testing was done virtually, which led to our 3rd limitation, which limited the amount of contact. It was a bit difficult to have thorough sessions over Zoom with 1-hour blocks each. From user testing, we gained 3 main insights. Our first insight is that Verena, while we thought it was easy to use, had a complicated interface for users that were not comfortable with the app. They had to click through multiple buttons to get to their questions, and so they indicated that it needed to be simpler. They compared our app currently to a form-fillable PDF, which is one of the current means for filling out crashes. They liked that it was simple and they could find all of the questions by just scanning through it. Our second insight was the division of on-site and off-site use. On-site would be when they're filling out the report at the crash site versus off-site when they're back in the office filling in extra data. At the moment, Verena presents all the questions to the users at the same time with no distinction. This makes it time-consuming and difficult for the users at the crash site to collect all the necessary information at the moment. Our second insight was the need for rural area customization. Both of our users groups were in rural areas. However, not all of the questions are specific for rural areas. For example, there are questions about highways and interchanges, but most of our users only had 2-lane roads. This emphasized the need for question customization. With these insights, we use these insights to help guide our liaisons in the future development of this project. Now we can see with Arena the ecosystem change. With Arena, we introduced a mobile report. With the mobile report, we have automatic data capture, intelligent tools that increase the data integrity and offer standardization of the data. With the standardization and increased integrity, we see higher data consistency and an increased reporting. Thus, city planners and public policy experts now can make informed infrastructure decisions. Now, Verena will be handed off to our liaisons at the Volpe Center for Future Development. Some of the future steps for Verena is integration with data analysis tools, an extension to other platforms such as iOS devices so that we can expand the reach of Verena. Last but not least, we'd like to thank our liaisons at the Volpe Center, Alex and Angie, our additional advisors, Adam and Tom, our academic advisor, Jason, and our subject matter experts, Katrin and Ricardo, and our sponsors, Paul, Santos, and Ann Stewart. Thank you.
Is this better? Yay, okay. Hello and welcome. We are the Watts Water Energy Harvesting Team of the 2021-2022 Scope Program. We are Alex, Becca, Kyle, Nathan, Sophie, and I'm Mary. We would like to thank our Scope Advisor, Alessandra Frizzoco, as well as our sponsor liaison, Joe Burke of Watts Water. Special thanks as well to Kevin Simon, Jessica Townsend, and Emily Tao, who offered their expertise to our team. Our project involved harvesting energy from pipe flow to power remote data collection. Our sponsor was Watts Water Technologies. They are a global leader of quality water solutions. They provide an extensive range of plumbing and flow control products that's designed to facilitate efficient water conveyance and control for commercial, residential, and industrial applications.
As a result, they've started producing several lines of interconnected smart technologies. These IoT or smart devices are becoming more prevalent in water infrastructure today. But why does this matter? Well, the short answer is that distributed infrastructure and IoT flow monitoring are becoming business priorities for Watts. The longer answer is that networked flow sensors provide very important water quality information that can be used to monitor water quality and usage, as well as a form of leak detection. This also can be used as an effective way to allocate different resources that helps us provide an improved understanding of individual and community water consumption. It can also be used to plan for when resources become a bit more scarce, which you'll hear a little more about when the other Watts team comes up. Our project was designed to solve the lack of easy access of electricity for Watts' sensing devices. Batteries and other forms of external sources of electricity aren't always cost-effective or logically feasible. Batteries need routine replacing, and external sources of electricity aren't always run right up to water mains. Our solution is, we developed a solution to generate electricity from the water in the same pipes where these sensors are being held. This allows no further restriction on wider water mains and is also designed to be installed in front of existing PRVs or pressure-reducing valves, which allows us to use the pressure drop from these valves to produce useful work instead of that energy being lost as heat. And it worked. We proved that powering a data logger from flow energy is highly achievable. Furthermore, the low energy capture requirement allowed us to look through cost-effective solutions. Our device is small scale, simple, and inexpensive, a model of which is shown here on the right. But how did we get there? We started this project by doing research into pre-existing technology in this field, mainly turbines, specifically turbines that recover energy from water flow. We compared the efficiency, size, and flow rates of the different designs we found, and found that efficiency very well correlated with the Reynolds number, shown here. From there, we entered our design phase, which took up the vast majority of this project. We designed several different types of turbines using rapid prototyping and 3D printing abilities to let us quickly iterate through designs. We went through many different styles of turbines, including centrifugal-style turbines, shown on the left, paddle wheel turbines in the center, and axial-style turbines, shown on the right. As we went through this design process, we were able to test our prototypes in our testing rig in order to gather data so we could compare the performance between these designs. Our testing rig, shown here, has water flow running from right to left, and the test section in the center would be replaced with our prototypes during testing. The pressure and flow sensors on either side of that test section let us gather data so that we can run an analysis on our different designs. Throughout this process, we iterated on several different blade designs. We changed the shape, style, size, number of blades, and blade angle throughout this process. Overall, we found that by varying our blade angle, we could change the resulting efficiency of our designs. Overall, more aggressive blade angles resulted in overall better performance. And we came across 2 designs at the end that successfully met our energy requirements. Our final design is a centrifugal-style turbine with a scroll housing inspired by automotive turbochargers. The scroll housing, shown here in white, was standardized, allowing us to quickly iterate on different turbine designs, shown in red, and quickly swap them in and out for design. We added magnets to our turbines that allowed us to use a Hall effect sensor to capture RPM data. We used a multi-rotor motor as a generator, and designed our own generator mount and backplate, shown here in gray and blue. The mount and backplate assembly were also standardized, and this was very important for our design process because it allowed us to very quickly swap out turbines without needing to print a new housing every time. So what's next? Well, either Watts or a future scope team is going to continue this project. Future progress in this project might involve certain design improvements, such as fine-tuning tolerances or working on non-3D printed materials, getting this ready for production. Overall, it'll be work to make this even more efficient, powerful, robust, or operable on larger pipe diameters. Additionally, a battery charger would need to be implemented to transfer the recovered energy from our turbine to power IoT devices. And also, a future team might decide to go further into looking into turbine design, which, as we found, is a very vast area of study. We learned a lot through this project, and we're excited to see where Watts and/or a future scope team take this in the future. Please feel free to stop by our table after the last presentation for our poster session, and thank you for listening.
Hello? Good. All right. Last one. Hello? We are the Watts Water Future of Water Infrastructure Scope Team, and welcome to our final presentation. My name is Lauren. I'm here with my two teammates, Katie and Jamie, and Carlos unfortunately could not join us today. This project was inspired by recent reports that predict we are heading towards a global water crisis. Projections show that water demand will outstrip supply by 50% by 2040, meaning that in about 20 years, we will need to supply more than 50% more water than our current water infrastructure can provide. In August of 2021, the International Panel on Climate Change also released a report that states we are in a code red for humanity with regards to the water crisis. They predict that intensified water cycles will lead to increased risk of both flooding and drought, causing significant strain on our current water infrastructure and impacting our ability to allocate water where it's really needed. This will lead to an increase in frequency of what is called day zero events. A day zero event is when a municipality's water supply drops so low that they're forced to shut off their public water infrastructure, instead resorting to rationing water to citizens. The most well-known example of this occurred in 2018 in Cape Town, South Africa. They made preparations for a day zero event in response to a significant drought they were experiencing. Luckily, strict water-saving measures and some well-timed rains meant that they were able to narrowly avoid having to implement a day zero, but we can't rely on the same luck next time a region is in the same situation. And we're increasingly seeing worse drought conditions in many areas of the world than we've ever seen, increasing our risk of day zero events. This is why our team worked this year with Watts Water Technologies, leaders in plumbing technology innovations, on a research report that will help inform their long-term future product development and strategy setting. We set out to answer two large questions. How will our water infrastructure change in response to increasing drought conditions and the water crisis? And how can Watts use their existing expertise to contribute to preventing day zero situations in the future? So to answer these two very broad questions, we first need to understand a little bit of how our current water infrastructure system works. And it's largely linear. Water is pumped out of the ground from sources like reservoirs or aquifers. It's treated to local drinking water or potable water standards, and then it's transported for end use. And the three main water end uses include industrial, which includes factories and power generation, agricultural irrigation, or residential end use, which is the water we use in our homes or in other urban buildings. Once that water is used, it's transported to your local wastewater treatment plant, treated, and then dumped to surface water as waste. And with this linear system, we soon realized that we're doing some pretty unintuitive things. About 1/3 of the water that we use in our homes is used for things like toilet flushing or clothes washing, things that could be using non-potable water that we're currently accomplishing with treated, fresh drinking water. And zooming out, we can see that about 90% of the water that we pull from surface or groundwater sources ends up in industrial or irrigation end uses, things that we're also largely using potable drawn water for. Enter gray water reuse systems. These are systems that can take water that is produced from things in our house like sinks, washers, showers, that are minimally contaminated with organic materials. This water can then be retreated and redirected for other non-potable end uses, like outdoor irrigation, industrial processes, agricultural irrigation. And think of how much our water supply gap could shrink if instead of treating and tossing all of our gray water as waste, we were able to redirect that water for other uses. This is why our team focused this year on understanding reclaimed water, for its potential to meaningfully address water scarcity in the water crisis, and also for the unique and specific water infrastructure it requires that opens up opportunities for Watts' current product lines and expertise. This may seem like a water system of the future, but many regions are already implementing recycled water at a large scale. For example, San Antonio. In an effort to reduce their reliance on the depleting Edwards Aquifer, San Antonio is investing heavily in their reclaimed water infrastructure. So much so that they currently boast the nation's largest percentage of reclaimed water, meaning recycled water makes up about 16% of their total water usage. Florida isn't necessarily a region that we associate with water stress, but depleting aquifer levels and rising seawater levels threaten to contaminate many of their freshwater sources with salt water, which is costly and very difficult to reverse. In response to this, Florida is investing heavily in their own reclaimed water, as we can see from this bar chart that shows Florida's recycled water capacity over time, increasing significantly in the last few years. Florida also recently passed legislation that will require all public utilities to completely eliminate non-productive wastewater discharge by 2032. This means that all water in Florida will have to be reused in some way, whether it's being retreated and redirected for other applications, or discharged in a way that helps maintain aquifer or reservoir levels. In the early 2000s, Australia experienced their worst drought in recorded history, the Millennium Droughts. They, in response to this, invested in climate-resistant water sources, including reclaimed water. And by 2006, many areas of southeastern Australia were connected to a purple tap system. And the purple tap is a dual potable and non-potable water system for residential use, where they're able to supply recycled non-potable water to homes for uses like watering your lawn, washing your car, and other outdoor uses to make them more resilient to drought. Our final deliverable to Watts was a report in 3 parts. One section that focused on an overview of on-site water reuse systems, including case studies like the ones that we just went over, as well as a section investigating potential public and private partnerships for Watts to enter the reused water space. And then we took a look at the state of water reuse regulation in the US and what that might tell us about future water reuse adoption in emerging markets. We hope that this report will help Watts be proactive in responding to our water crisis, help them assess the viability of emerging water reuse technologies, and ultimately contribute to a water-conscious future. This report will also be used as inspiration and research background for future Watts Water Scope projects. Thank you, especially to our Watts liaison, Joe Burke, our Scope advisor, Jessica Townsend, and to the Olin Scope program for making this project possible. And we look forward to seeing you all out on the O shortly.
Okay, well done. Students, I wonder if you could just turn your heads back a little bit and look back in the back. And I wonder if we could, no, just the students, everybody else keep looking forward. Can we just give these folks another big round of applause? Y'all did such a great job this year and today with your presentations, and we look forward to talking with you at your posters. As a quick reminder of our schedule for the day, we're just a couple minutes over on our presentations, but we got a 15-minute wiggle room to head out toward the Oval for the poster session. One quick note to students, if you can get to your posters and have your whole team there at the poster for about the first 15 minutes, we're going to get team pictures, which we haven't done yet this year. So we'll do that. And everybody else, come on out at your leisure. There's refreshments out there. And just a quick note to say farewell for now to Scope. Being on faculty at Olin is the best job I've ever had by miles, and being Scope Director is the best part of that job. The students are incredible. I love Scope Wednesdays and sitting with you and seeing what you're doing on your projects and hearing your ideas and engaging with you. The sponsors bring these really fascinating projects like harvesting energy from a pressurized water system that as an atmospheric scientist I would have never thought about, and it's incredible to engage with problems like that. And this is the best team and the Scope leadership team that I've ever worked with in any context of my life. Ruth and Jessica, you are Scope. When I was asked to be Scope Director, I said, sure, as long as Ruth and Jessica will do it. So thanks for working with me these last 3 years, and every teaching team that I've worked with has been just phenomenal, so thank you all. Also want to take just a moment to introduce Sarah Bloomer, who's our incoming Scope Director. I can't wait to come back from sabbatical in a year. Well, actually, it'll be like a year and a half now, and see what new is happening in Scope. So really look forward to having you here. Okay, that's the end of our program here. Thanks again for coming, and look forward to seeing you out in the poster session.